Okay, we're going to be looking at the equations and gradients of lines which are perpendicular to each other today. So first of all, to check that you have some knowledge from before that you can use. So these four lines here, if you can't tell me the gradient of what these lines would be if you drew them, you aren't ready to do this task. So go back and do the previous work to make sure you can tell me that this has a gradient of 3, this is a gradient of -3/4, and so on. Also, from these four lines, 2 of them are parallel, and if you haven't identified those or can't identify those, again, this is the wrong video, you should be going back to something else first. And in this case, these 2 are parallel because they have the same gradient, and that means they're going in the same direction, and that is the definition of parallel. So, moving on to perpendicular lines. Here is an arbitrary line, and we like to find out its gradient. And the way you have been taught to do that, or should have been taught to do that, is that you think about how far right, or xward, it's moving, and how far y-ward it's moving between 2 points. And these 2 points can be anywhere on the line, but we always think about going right and up. And it's strictly right. If you have to go down, that's fine, that gets you a negative value. So these will have completely arbitrary values. We can make up what these coordinates are, and I don't care where these are. These coordinates could be here, or here, or here, or here, or over here, and they'd have the same slope. So this distance would be preserved. So let's just make up a number. Let's say that that is 12 units right, and that is 8 units up. So you should be able to tell me that gradient, so right is positive and up, that gradient is 8/12, which simplifies down to, divide it by 4, I think, to get 2/3. And we call that m, or sometimes we use delta y and delta x, depending on exactly which notation you see. So that's just finding a gradient. I've made up these numbers, but if you had coordinates you could count or work them out. Now I'd like to think about this being perpendicular. So I've traced this out already to match up, hopefully. And if I rotate this 90 degrees, that line will now be perpendicular to this line. So if they cross, there'll be a right angle where they cross. So, what has that done to these 2 values? That 8 is here, and this 12 is here. So if we turn that, that's moved that way. So if I switch colour again to show you the new thing, starting with the left coordinate and we move right, that is this distance, which is the short one, which is 8, positive 8. And then this must be the same as that, which is the long one, which is 12. But this time we've moved down, it's -12. Okay, so we have the same distances, which means we have the same numbers, but they've swapped which one is horizontal and which one is vertical, and we're going down instead of up. Or if we started here and went here, we're going up instead of down. So that means there's been a swapping of the values, and one of them has changed sign. So that means the perpendicular gradient, which I'll do in black to master, so I'm going to put a perpendicular symbol, gradient, is -12/8. And -12/8 simplifies to -3/2. So there is a numerical relationship here which we can do directly. If I give you a new gradient that you've never seen before, like 17, let's do -17/23. So that's the gradient of some line, believe me, it's just a number. How could I convert that to the gradient of a line perpendicular to it? Well, if we look here, we see the numbers have swapped position. They've gone upside down as a fraction. That's actually called reciprocating. And where this was positive, this is negative. And it's true the other way as well. Where this was negative, this becomes positive. So that will be positive. So I like to use a symbol I borrowed from chemistry about the reversible reaction thing here to show that these are related but not the same. So this is the negative reciprocal of that. And as a final check, if you multiply these together, you will always get -1 if they are truly perpendicular. So if gradients are perpendicular, they will multiply to -1. You can relate them by reciprocating and changing the sign. So let's apply that to a problem. So here's what I've written earlier. We're going to find the perpendicular bisector between these 2 points. So we need to know what a perpendicular bisector is to start off with. From your work in construction, you should know that's a line that cuts through at halfway at right angles. So right angles comes back to this perpendicular thing. Halfway will take a little bit of work. So if we call this point A and this point B, M is the midpoint in between them. And we can find that by taking the mean X position and the mean Y position. So that is 7 and that is 3. So halfway between these 2 points is the coordinate 7, 3. So that's the point we're going through. But we need a gradient as well. So to find the perpendicular bisector, we need to first of all find the gradient between these 2 points and then make it perpendicular. So the gradient between these 2 points is the change in Y over the change in X, which is 8 take negative 2 divided by 11 take 3, which gets me 10/8, which simplifies down to 5/4. So that's the gradient between A and B, because I used these 2 points. I've got to make this perpendicular now. So the perpendicular gradient, we're just going to swap that over, so we get 4/5 and make it negative. So that's the perpendicular gradient. So we've got a coordinate and a gradient. We've got all we need now to write the equation of the line. There are a couple of ways to do this. If you've been in my class, I've showed you my preferred way, which is to use the full formula, direct formula, which is this one. So Y take away 3 is negative 4/5 of X take away 7. So the 3's gone in there, the 7's gone in there, and the 4/5 has gone here. That's the thing we're quoting because we've seen it before. So if you don't recognise that, you've got to look it up or use the other way, which is to use Y equals negative 4/5 of X plus C, and then use these values to work out what C needs to be. That's using the Y equals mx plus C. I'm going to finish this off now. I prefer to end up with integers, so I'm going to multiply up by 5. So 5y take 15 is negative 4x plus 28. So I've expanded the bracket and multiplied through by 5. So we add 4x, we get 4x plus 5y is 43. And that's been simplified now. That's not the only way to write this, but that is an acceptable way to write this that has all integers, although it loses the gradient explicitly. So, the key thing here, the key new information, in fact the only new information, hopefully, is that if I give you a gradient, you can find a perpendicular gradient by doing the negative reciprocal. So to pick another one at random, let's do 45 153rds. So that's some gradient of some line. The perpendicular gradient to that is negative 153 45ths. And after that, you can do any other line gradient problem once you know that these two gradients are perpendicular. Let's probably just show you one that's got a simpler fraction. So negative 1/2 would go to positive 2, and the way to think about that is that's 2 over 1. And again, it satisfies the multiplying to make negative 1 rule. So I hope that's covered enough for you. Do get in touch if that's tricky. Good luck.